In this lesson, we use first principle and find derivative of some functions in general. Derivative of f of x equals c is 0. Notice that limit of f of x plus h minus f of x divided by h as h approaches 0 is 0. Derivative of a linear function is the slope of the line. F prime of x is limit of m times x plus h plus b minus mx minus b divided by h as h approaches 0, which is the same as limit of mh over h as h approaching 0. When you reduce it by h, the limit would be m. The limit of f of x equals, the derivative of f of x equals xn is n x to the power of n minus 1. We know f prime of x is limit of x plus h to the power of n minus xn over h as h approaches 0. If we expand the numerator using binomial theorem, we have xn plus n xn minus 1 h plus 1 over 2 n times n minus 1 x n minus 2 h2 plus hn minus xn over h as h approaches 0, which is the same as limit of, if we divide numerator and denominator by h, we get nxn minus 1 plus h times a polynomial. As h approaches 0, this limit is n xn minus 1. To summarize this, we learned derivative of a constant function is 0. Derivative of mx plus b is m, and derivative of xn is n xn minus 1. Using first principle, we can prove derivative of a constant times a function is constant times derivative of the function. Derivative of addition or subtraction of two functions is addition or subtraction of the derivatives. Therefore, derivative of c times xn would be cn xn minus 1. Let's have a couple of examples. Find the derivative of each function. Y equals 5 root 2. The derivative of y equals 5 root 2 with respect to x, which is sometimes denoted by dy dx, is 0. It's a constant function. Derivative of a constant is 0. It is similar to saying y prime is 0. Derivative of y equals 2x plus 3 with respect to x is 2. dy dx is 2, or we can say y prime is 2. Derivative of y equals 7x3 is 21x2. Derivative of cxn is c times n, x to the power of n minus 1. C in this question is 7, n is 3, cn is 21, n minus 1 is 2, 21x2. Derivative of 5x3 plus 11x2. Derivative of addition of two functions is derivative of the first one. 5x3 is 15x2, 5 times 3, 15, 3 minus 1, 2, plus derivative of the second one is 22x. 11x5 minus 9x4 plus 3x2. Derivative of addition or subtraction of the functions is addition or subtractions of derivatives. 11x5 is 55, 5 times 11 is 55, x to the power of 5 minus 1, x4, minus 4 times 9, 36, x3, plus 6x. Derivative of y equals 2x, 2 plus 6x plus 5 is 4x, and derivative of 6x is 6, and derivative of 5 is 0. Therefore, the derivative of 2x2 plus 6x plus 5 is 4x plus 6. In this lesson, we learned derivative of a constant is 0, derivative of mx plus b is m, derivative of xn is nxn minus 1. Derivative of a constant times a function is constant times derivative of that function. This can be proved easily using the first principle and knowing that limit of a constant times a function is constant times limit of the function. We know limit of addition or subtractions of two functions is addition or subtractions of the limits. If we apply first principle to the left side of this relationship and use the property of limit, we get the second part. From this, we have derivative of cxn equals c times n, x to the power of n minus 1.